Good day, everyone. So for today, we'll be doing the Arduino program for blinking LED. So we'll start with the circuit diagram using Proteus, and then we'll write a code to the sketch of the Arduino, and then we will embed the code to the Arduino itself. Okay. So first thing we need to do is to create the circuit. No? So go to your Proteus. Last time we've discussed about how to add libraries for your Arduino. So this time we'll be directly doing that and using that for us to we'll have a name blinking. We'll replace, so we'll create a schematic, but we will not need first our PCB, so do not create. Then we don't need firmware since we'll be using Sketch, so finish. And after that one, we include parts. In our case, we'll be using a LED, one LED, and an Arduino. Okay, now we'll have Arduino. So Arduino. So we have here Arduino Nano. So you can click this one. So as I've told you, you could add your library, Then after that, we add the LED. When choosing the LED, you need to choose a LED for or has an active status like this. This have a color, so let's say yellow. So yeah, we only need that one. We use resistor to limit the current, so let's say resistor. So let's just have E. Okay, let's use generic one na lang. Okay. After that, we just click the parts. Click it here, anywhere you want. Then we'll try to add the LED. After that, at first we'll be using a pin number 13. So in this case, we could directly connect it. So click on that button, click, and then click on this part. Then we'll connect it to the ground. Oh wait. Okay. We need a power source. You go here, the terminal mode. You go to power, and need a ground. Okay. So you will know that you are in the ground. So you see this one, tip of this triangle with a line. That is where the ground should be connected. So connect it there. After that, supposedly, as I've told you in the class, this should be connected to the VIN, but instead, in this case, actually you may not put it here in simulation, but in actual, you need to power your Arduino so that it will work. So in this case, we just put this one in the 5 volts, but do not do this one when you do the actual, So G is for the ground, connect it here. So this one should be connected to your VIN, okay? Or if you don't want to use this, you could use the USB port to power your Arduino. Okay, after that, you have this circuit. So now we need to run this schematic. So from here, we cannot run this one since we still don't have a code embedded here. So we'll go to Arduino. So I expect you already download Arduino. So simply clicking that one. After that, wait for a bit. So after that, you click new. So I close this one. Okay. So from here, we need to declare. Okay. So you may not declare it, but I suggest that you declare variables closer to its functionality so that it's easy to debug if there will be errors in the long run. So you put int, then will be the one that is connected. Remember, the one that is connected to your Arduino is only the LED, okay, except for the power. So we use LED. And where did we connect our LED? In pin number 13. So we put here equals 13. Now, in the void setup, it's where you define what's the functionality of the input or output that is connected to your Arduino. In this case, our LED is connected to our Arduino. So we declare what is the function of this LED. Pin, and capital M, pin mode. Okay, so you put LED, and what's the functionality of LED? So it outputs light. So therefore, it is output. It should be written in capital. After that, in your loop is where an infinite process, it loops back and back. Okay, so this is where we want to write our code. So at first, we want to start our LED to light up. No, we want our LED to light up. Okay, so this one, when we play this one, there's nothing since there's no code inside. So from there, we put, remember, where did we put our pin number 13? So it's from the D, meaning from the digital. So if you could recall, this one is called the digital inputs and output pins. So digital. Okay. So 13 is in the digital pins. Therefore, what we write here for output, it's like you're basically display output. If you're using C, that is where comparable with your printf, but printf display in the screen. For here in Arduino, since you put it in the embedded, it is where your Arduino release signals. So digital write. So you want to write something, you want to give a signal out. So digital write, what you want to write? The LED to be high, because we want it to light up. So from there, let's try to check whether there is an error. So you click this check button. So try to save that one. So blinking, save. So there is no error. From there, if you have an Arduino, physical Arduino, what you need to do is to plug your Arduino together with the cord and the port and plug it to your USB port in your computer. After that, you choose the Arduino that you are using. For me, I use Nano. Then check the port. Since I did not use any physical hardware, so the port will not be present. So if it is, just use that one. So after that, since we'll be using Proteus for simulation and not the actual physical hardware, so you just need to copy the hex file. Okay, and Control C. Okay, I click Control C to copy it, then you need to go to Pro Choose. Click the IC button, or IC, and you paste. I Control V, I paste it and click OK. After that, you try to run the code, and what you could see is a steady light of the LED, which is not blinking. Because if you could see, our code states that it will just light up. So what we need to do is to turn it off, then turn it on again. So if I put this one, digital right, sorry, what will happen is these two code will run simultaneously, which we cannot appreciate the difference between the two outputs. So what we need to do is to have a delay between the high and the low. So meaning, first it will light up, then for a bit of seconds, depending on you, we will turn it off, then a bit of second, then we'll turn it on. So the function that we use is delay. So from that, remember 1000 is equivalent to 1 second. And after that, it lights up, it turns off for 1 second, then it changes again, delay 1000 for another second. Since this void loop is an infinite loop, after a delay of 1 second, it will repeat back to the first. Okay, and let's check it again if there will be an error. If there's no error, you check and find the hex file. Okay, the hex file is here. Try to copy that one. I click Control C, then go to here, stop the running, and click it again, and replace, and click OK, and then click run. So what should be observed in the LED? It should blink by 1 second. Okay. So now you could see the changes in 1 second. But again, so let's stop this one. What if, sure, will it still work if I put it to a different port? Okay, so is it always in pin number 13? The answer is no. So you could put it anywhere. Again, you could directly put it here, 11, 12, 13, 2 to 13, depending on you. You could make it in anywhere. Here in pin number 13, it is directly, since you have already resistor within this one. But again, outputs of here has not that much current, so if you have LED that can sustain that one, it will not damage it easily. But there are some that, to make it more safe, they will add resistor. So let's change the resistor. Again, you calculate the resistor, how many voltage will be here, what is your desired light intensity, so that you could change the value of the resistor. Let's say I just put 330 ohms. So here, connect this one to this. Then I choose maybe pin number 4. Okay, let's say like that. Then what we need to do is to go to our program. Remember, we change it to pin number 4. Okay, so meaning here we need to change it also in pin number 4. You don't need to change this one since it's still output and still in digital 4, still in digital pins. So what you need to do is just replace, so that you could pinpoint where should this digital write signal high should go. So by doing this, you could tell that this high should go to lead, which is connected to pin number 4. Okay, so the pin number 4 will be high, low, high, low. Okay, so let's modify. Let's run it again. Don't forget to run it every time. Check it. Then after that, copy the code again to change it. Control copy. Go to ProTools, change it. Control A, paste, then click OK. And after that, let's run it. As you can see, it's still the same. Okay, so meaning anywhere you want, you could do that things. Okay, so let's say another thing, if we want to make a series of lights, okay, let's make plenty of it. So let's say I will make many of this. Stop the running, and then I'll put it here. Okay, I'll make it plenty of this. Okay, delete the wire. Okay, I'll change it here. I'll change this one. Okay, I'll rotate. I copy. Okay, then we'll create block copy again. Okay, so let's try to make this one, and then I'll try to add resistors that are different colors, or LED which has different colors. So I'll find blue, maybe green, red. Okay, this is bicolors at 2 colors. So if you could have this one, it's 2 colors. Okay, so let's try this one. I don't usually use this one. So 2, 4, we add blue, then we add green, then we add red, and let's try this one. I don't know what's the output of this one. Then we can connect it to the ground. All of this, since should be connected to the ground. So our LED, the other side will be connected to the negative, and the other side will be connected to the positive. All the outputs of your Arduino is positive. Okay, so always remember that one. So the output that the signal gives from Arduino is all positive. So let's try to connect this one. Let's maybe try it in 3. Oh. Okay. 3. Maybe next is in 5. So just do alternate. And maybe here. So again, it depends on you where you want to put it. So maybe next one, and maybe the next one will be in 8, and the other one maybe we'll connect it in 11. Okay, now let's connect that. Remember what are the pins that we use. Let's say LED yellow, LED blue, green, red. Okay, much better we put side by side so that it will be easier to code. Okay. Okay. So now we have LED. Let's say yellow. Let's start with LED. This one. that is LED blue. This one, LED blue. So we connect that one in pin number 3, sorry. The next one is int LED red. We connect that one at pin number 5 and 6. 5, then int LED green. Next is green equals pin number 6. Int blue. Oh, what's this color? Oh, big Y. Sorry, that is not blue, it's big Y. This is the blue. Okay, equals, the blue should be connected to pin number 8. Pin number 8. And the last one, LED yellow, will be connected to pin number 11. So from here, we write to write this one. So we have this big Y. Sorry, big Y. Next is red. Next is green. Next is blue. And last is yellow. Okay. Now we all declare that these are all outputs. Now what we need to do is to run the LED. So alternate. So it will start with the LED big Y. No? So high. LED big Y high. Next is the LED big Y will still be high. Then the next one will be high. What we want is we'll light this one light, this one will be light, 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 then off. Okay, then repeat it back. Okay, so from there, big Y, then red, then just copy this one to make it faster. So from here, red, next to red is green, next to green is blue, and lastly is yellow. No. So after all of this LED lights up, we will turn it off, every one of them. This one at the same time. So I'll be lighting this one too at the same time, right? So that's why we try to big red, green, blue, and yellow. Then the last one is yellow. So from there, I'll change this one to low. Okay, then delay 1000 again. Okay, so it will repeat back. So let's try to run it. check if there's an error. Where? Okay, LED blue. Hi, where's the error? Was not declared. Yeah, that's the reason why. Okay. Okay, there's no error. So in this case, we copy the hex file, this one, until here. Control copy. Now we go back to our code. Okay. So we put the code inside, Control A, paste, and click OK. Then let's run. Siga. Then light up, and it light up. Then off, turn it on. And I think with this example, we know how to output signals from our Arduino to our output device such as LED. So next meeting, next discussion, next example, now we will try to input something to Arduino. Okay, so I think that's it, and hope you learned something.